request to be a.
So you guys
Infinity on the bottom.
request to do an example problem before we take this homework quiz,
Please
that's
do.
fine. Okay, our example problem, x squared plus 5x plus 6 over x squared minus 9. First step,
Factor.
factor. How does the numerator factor?
X plus 2 and x plus 3.
Okay. And how does the denominator factor?
X plus 3 and x minus 3.
Okay. Stop here. We can do the domain. How do we do the domain?
Do we have an RD? Oh, we do have an
Is it
RD.
negative?
So we set the denominator equal, or not equal to 0, we should
Oh,
say.
yeah. Wait, will you mark this down if we do not equal to 0?
I'm gonna worry more about the final answer.
Okay.
So we get that x cannot be negative 3 or positive 3.
Yeah.
Everybody's okay?
Yeah.
How do I write that as an interval notation?
Negative infinity.
Negative infinity, then negative 3. And then union, negative 3. And then negative, or 3 and positive 3. Or positive infinity. I'm
Do we need to put the positive in front of the infinity?
fight someone right now.
I always do,
Fight the
but you don't
board.
need to.
I feel like
I'm so cool.
I have to that.
I don't wanna get fight.
But then don't take it. Go tell you. I don't know. Go to the bathroom or something.
Question on the domain.
No.
No, that is okay. Is that a fidget?
Back to here. Once we've factored and done the domain, what do we do next?
RD.
Try to reduce. Is there anything to reduce?
Yes, plus 3.
The x plus 3's.
From Michael's.
What does that do?
It gives us the
Gives us RD.
Creates a removable discontinuity.
removable.
I'm gonna start celebrating during this.
Okay? So I set the piece that I crossed off equal to 0, but a removable discontinuity is a point, right? It's a location, so it has a y coordinate also. How do I get the y?
You put the x into the equation where s is.
I plug the y, or the x into the reduced equation. Just take your value for the removable discontinuity, plug back into the reduced equation, that gives you the y coordinate. So it's x comma y. Okay?
That's for RD.
That's the whole, yes, that's the same thing as removable discontinuity as a whole, yes. If you prefer that. Okay. After the removable discontinuity, I should find the
BA.
vertical asymptote. How do I do that?
Set the denominator to 0.
The reduced denominator equal to 0. Done.
HA or OA.
Okay.
Have to look at the equation.
This is where I messed up.
Okay. What do I need to look at?
Take exponents and then
The degree of the numerator and denominator. Degree in the numerator is?
I don't know.
1.
The degree in the denominator is?
1.
Is it
Because they are
Equal.
x to the firsts, right? The 1 is coming from the exponent.
Are you looking at the reduced one?
Yes.
The HA then?
Yes, so if they are equal, it's an HA. Or if the numerator is less than the denominator, it's also an HA.
Okay.
But the way to find that equation is different. If it's greater, it's the OA. You find that doing polynomial division. This is an HA though.
How does it your last class?
Since they're equal, how do we find the HA for equal?
Is it the top divided by the bottom?
Leading coefficient
Oh, we.
of the numerator divided by the leading coefficient of the denominator.
So what's the
So is that 1?
The leading coefficient of x plus 2 is
1.
1. Of x minus 3 is?
So it's
So it's y equals 1. That's
I'm
it.
sure the 1.
So I can assume safely it's gonna be 1?
No.
So
It's gonna be leading coefficient in the numerator over leading coefficient in the denominator, provided the degree of the numerator is equal to the degree of the denominator.
Wait, so
Wait, what?
Mr. Cooley?
Bigger on bottom.
If the numerator is bigger than the denominator, that's still HA.
That's an OA.
Oh, sure. And then if the numerator is less, it's HA.
That's an HA, and it's always y equals 0.
Oh,
Are you gonna graph this?
Am I gonna draw the graph?
Yeah.
Sure.
Okay, cool. We don't have to graph it, right?
I don't think I asked you to graph anything
Oh,
on
you
this.
don't?
So now we have to find the x-intercept.
Okay,
Isn't the denominator set it equal to
we plug 0 in for y.
Oh.
Actually,
Okay.
that's way too.
Wait, are we gonna have to find H?
I know to get the first part.
What's H?
The one that you put over X?
I'm unsure of what you're asking.
That's great. No, right, okay. That's fine,
Okay,
that's fine. Okay.
so we're gonna find the x-intercept next. So I plug 0 in for y, and then I solve for x, right? What I have as a fraction is equal to 0. When is a fraction equal to 0?
One less
and the numerator is.
When the numerator is 0.
Right, okay,
So there's my x-intercept.
Oh, because, okay, so you got that. How?
Put 0 in for y.
If I put y equals the equation, you put 0 right here. And then the only way it equals 0 is when you create it. And you just put the numerator.
Oh, okay. So why'd you not, okay, the numerator is
Next I do
There's more?
Don't you do the
The
opposite?
y-intercept.
the y-intercept.
How many questions is this quiz?
It's probably 1.
4.
Do you have to substitute the -2 for the original equation?
No,
For the x's in the original equation.
I plug 0 in for x.
Oh yeah, because we have to find the y-intercept, that makes sense. Right.
So it's just 2
Just double checking, I got the plug 0 in
Wait.
for
Wait.
It's not the X, we just
We have to do that, and then
Wait.
maybe we
Wait,
don't have
after
to.
somebody
Zero in.
Wait, and that's it? That's it? Is that what we do? We don't have to
Yeah,
graph
that's what
it? Okay. That's all you needed?
Yeah, that's all I
X
need.
intercept.
You wanna see my egg?
Y-intercept, yeah, an X.
Your egg.
Very good.
Yeah, I have an
Good.
egg.
You wanna see it? Is it like a
Yeah.
Are we gonna do the
element?
We're doing it right now, yes.
Yeah, we're doing that right
Well, what is EV?
The last thing we're gonna do is the end behaviors.
It's color changing too.
Okay. How many end behaviors should we write?
2. Oh, definitely. So,
How many?
2.
4. Very good. What are the 4 that have the right end and left end? That's x going to positive infinity, negative infinity, and then you have, and then 2 for each vertical asymptote. One on the left side of it, one on the right side of it. Okay?
Do better, John.
Right, that was the, oh, it's positive 3.
Come on, dude. Please tell Gio to walk in, or else he's not gonna have conversation. Yeah, you're not gonna have conversation. I don't really know.
So I have 4 end behaviors. I have the left end of the graph, that's as x approaches negative infinity. I have the right end of the graph, x approaches positive infinity. And then I have the left side and the right side of my vertical asymptote. So that's approaching 3 from the negative, from the left. That's 3 with the negative in the superscript. And then approaching 3 from the right. That's 3 with the plus in the superscript. Is okay?
Yeah.
All right. How do I find these? I use my horizontal asymptote. Yes. The left end and right end of my graph should be following my horizontal or other asymptote. So this is just going to be,
Wait, what?
the ends of the graph should be following the horizontal asymptote.
Yeah, because
Or should be following the other asymptote. So the other asymptote or horizontal asymptote will tell you the left end and right end behaviors.
So other is just slant.
Would be most likely a,
Massage and archive your whole body.
okay. Let's pick a value that's slightly less than 3.
Dude, how are we so
2.9.
2.9 sounds wonderful. When I plug 2.9 in top, I get a positive or negative value.
Negative.
Positive. When I plug it into bottom, I get a negative. Positive over negative is? Negative. When I plug in, let's pick a value slightly bigger than 3 now, say 3.1. When I plug that into top, I get positive. Into bottom, I get. So I have going to positive infinity. Done.
Okay.
Okay? If I want to put this all together now into a graph,
Oh, no.
To do that, right?
Oh, yeah, do we have to do this on the quiz?
look, you guys asked for an example.
No, I know, I'm just
You don't need
asking.
to.
Yeah, but now you confused me too much.
If the graph
brain
is
hurts.
It's okay.
I think my brain hurts too much to get to the quiz right now.
We can use all the information that we can get.
So I'm going to start by drawing the asymptotes.
So that would be the one that's on this part, right?
So that's y equals 1, that's the horizontal,
It's an easy one.
and x equals 3, that's the vertical, right?
Wait, where does x equal 3? Oh.
The vertical asymptote labeled as x equals 3,
Oh.
okay?
How do you feel about a partner quiz?
I don't. Now I'm going to plot my removable, so negative 3 and positive 1/6. I don't know, that's like right there. And I should draw that as an open circle, remember?
Yes.
My x-intercept is negative 2, 0, so that's there. And then I have 0, negative 2/3 for my y-intercept, so that's going to be like there. Everybody's okay?
Wait. What?
So I just plotted these 3 points.
Oh.
That's all I did. Okay? Now I'm going to draw in my end behaviors.
Yeah, Emma.
I want to start with my asymptote end behaviors. So the left side of 3 should be going to negative infinity. I'm going to pass through these guys and then follow the other asymptote. The right side of 3 should be going to positive infinity, and then I'll just draw it following the asymptote.
So it just mirrors itself.
It mirrors itself.
So you don't need to find any points on
I don't want to find your sketch.
It's not specific.
Go through the key points, but after that, I don't care, as long as it's reasonable.
This actually make more sense.
Yeah, I remember doing some stuff.
We have like
So graph, I remember doing that.
No.
We got this, bro. 79.
Okay,
Literally, that's it.
I guess.
Let's literally go. Let's just name it again.
Oh, we have
Mr.
more?
Kulik, if I had like a 92 in this class, would you go to 93 so I don't have to take a final?
92 point what?
This was just taught me.
That's just not how I see. That's just not how. Shut up, Mom. That's just not how I sound, though. That's just not how I sound. Like, you made the stupid voice when you did that.
I hate lectures.
Stop.
No, we're not actually talking.
I love the lectures now, actually. No, I don't, I still do them.
I hate that.
I hate lectures. Not stupid.
Oh, no. Oh my goodness.
Oops, not functions, equations.
Oh, I was so happy for a second. Stop.
All right. 14.2 is about solving rational equations. So equations with a rational function in it. I'm going to show you just one way to do this, the one way that can be used on every single situation, no matter the presentation. There's lots of other techniques that could be used that might be easier, but are a special case by special case basis. I'm just going to give you the one way that works in every single one. It's never terrible. Sometimes there could be a faster way, but in lieu of giving you a bunch of ways you could confuse, I'm just going to give you the one way that works every single time. We'll call it good. Everybody happy with that?
Yes.
Sounds like a plan, Stan.
I acknowledge that there are shortcuts that exist for certain situations. I'm ignoring all of those shortcuts and we're not gonna deal with them because I don't wanna confuse you and give you more than you really need. One method is good enough, that's all we're gonna do.
Got it.
Okay, all we're gonna do is a bunch of examples here using that method. I'm gonna talk through what the method is on the first one, and then we're just going to apply this method over and over again to solve.
Oh, that's getting. Oh.
Here's our problem. X plus 3 over x equals 4. Notice that I have an x in a denominator, right?
Yeah.
That makes this a rational equation. I have x's in a denominator. My method that I want to employ here is called clearing fractions. To do that, I'm going to multiply both sides of the equation by the least common multiple of all the denominators. So if I look at this problem, my denominators are 1, x, and 1. Everybody's okay? What's the least common multiple of 1 and x?
It's really hot in here.
X. Sorry. It's better than it being really cold like it is every other day.
Yeah. We should probably leave.
So,
Why is it X?
so if I do a prime factorization of 1, that's 1.
Yeah.
If I do a prime factorization of x, that's x. The least common multiple are the distinct primes, so 1 and x. The biggest power of 1 is 1. The biggest power on x is 1. 1 times x is x. That's how we make a least common multiple. Right, we did this yesterday, or last lesson when we added and subtracted. Right, you guys remember doing this? So I'm just going to multiply both sides of this equation by x. X times x is?
X squared.
X times 3 over x is?
1, no.
Is it 3 over
3x
x
over
squared?
x squared.
It's 3x over x,
Oh.
right? When you multiply fractions, how do we do it? Top to top, bottom to bottom, straight across, right? X times 4 is?
4x.
4x. 3x over x, what happens there?
The x is disappear.
The x is reduced. What type of an equation are we left with?
Difference of, no. You have to factor it?
What type of equation is this?
Rational equation.
Not irrational. Do you see adding x's in denominators?
Oh no.
Nope. It's a polynomial, great. To solve a polynomial, it must equal 0. So let's subtract the 4x from both sides to get it equal to 0. What type of polynomial equation is this? Starts with a Q. Quadratic. How do I solve a quadratic equation? I could factor or quadratic formula. Or if I had to, sure, yes. Or I could graph and find x-intercepts, right? Like there's a bunch of ways. What am I going to do for this?
Factor.
I'm going to factor. How does this factor?
X minus 1,
X minus 1, x
X minus 3.
minus 3. Multiply to give me positive 3, add to give me negative 4. So I have two solutions, 1 and 3.
Where's the zero? Where are the fours?
I factor.
Oh, okay.
I factor, right?
I was thinking about that too.
Okay. But I'm not done. I have to check one thing because I can get answers that aren't real answers. They're called extraneous solutions. Here's the check. These two values. I have to go back to the original equation and make sure that if I plug them in for x, I do not get a zero denominator. If I plug 1 into that denominator, do I get 0? If I plug 3 in, do I get 0? Then they're both good. Done. Let's do another. So here we have x minus 6 over x plus 1. What's my is this a rational equation, first and foremost?
Yes.
Yes, how do I know?
There's X in the
X in the denominator. Okay? How do I solve a rational equation?
I don't know.
Multiply by the least common multiple of the denominators. That is our answer every single time. That is called clearing fractions. Okay?
Oh, he put the answers right here.
What are my denominators?
1, X plus 1.
At 1 and x plus 1.
If it equals 0, if you did 3,
What's the least common multiple of 1 and x plus 1? X plus 1.
then that would work. So if you have the answer, then that would work. But if you have the 1,
Everybody's okay?
just 0 or 3 over 1 is 3. And then 3 over 3 is.
Multiply both sides of the equation by x plus 1.
As long as it doesn't
As long
equal
as you
0.
What is, so I have x times x plus 1
Oh, crap, what did you do?
minus 6 times x plus 1 over x plus 1 equals 0.
Oh.
Any questions on what I've done so far?
Would you like to pause for a minute?
Yeah, just submit it, please.
I'm still confused as to how you get the least common multiple. I don't know why I'm so bad at that. Like, why?
Oh, that's what you did, you did the least common. Okay.
So, Abby, what's the least common multiple of 2 and 3?
I'm so freaking good at this.
Boy, shut up.
Boy.
Isn't it 1?
It's 6.
7.
What?
The least common multiple is the smallest number that's divisible by both 2 and 3.
What number is it? 6?
So it would be 6. Since 2 and 3 are both prime, their least common multiple is just going to be 2 times 3. 1 and x are both prime polynomials because they cannot be factored any further.
Yeah.
Their least common multiple is just going to be 1 times x plus 1.
Oh, so that's just X plus 1.
That's it.
Yeah, bullshit.
What do you notice that we can do here?
Kids fight that one plus
Oh, get loud.
Oh yeah, you can cancel out, so it's 6.
And then let's distribute this through while we're at it.
x squared and,
What are we left with?
You can factor it.
It's a polynomial, specifically a quadratic that's factorable. How do I factor that, Gianna?
Put it in the x, -6 on top, 1 on the bottom. It's gonna be, -3 and 2. X minus 3, x plus 2.
Nope.
No, other way around, x.
oh, what the,
Plus 3 and minus 2.
oh, I have words with that. Oh, that sucks.
Is everybody okay?
Yeah, that sounds fine.
Am I done?
No.
No, what do I still need to do?
You have to check
I
it,
have to check. Where do I check at? The original equation. Where do I check?
the 6 over, yeah.
I just need to make sure that I'm not getting a zero denominator. Okay? If I plug with a -3 in, do I get a 0?
No,
If I plug +2 in, do I get a 0? What's that tell me?
you're right.
They both work. Done. Should we keep on going?
Yeah, please.
Yes.
Okay. They're going to get progressively more complicated as we go. Let's see what's next. In a moment.
Yeah, this one is a little darker.
Woof, Mr. Kulik, what the heck's going on with this thing? It's a lot of denominators all of a sudden. Thanks. Okay. What type of an equation is this? Rational. How do I know?
Because they're actually,
X is in the denominator. How do I solve a rational equation?
you have to find the LCM.
I multiply both sides of the equation by the least common multiple of the denominators. Now, the denominator x minus 1, that's prime. The denominator x minus 3, that's prime. But the denominator x squared minus 4x plus 3 is not. Right, that looks like I can factor that. Everybody agree?
Yeah.
I can't find the least common multiple until I've done a prime factorization of my denominators. So let's do that. Well, how does x squared minus 4x plus 3 factor?
X minus 3, x minus 1.
Okay. I'm just gonna write it down here.
Whoa, it's a 6.
So now I need the least common multiple of x minus 1, x minus 3, and x minus 1 times x minus 3. What will that be? That's correct. So x minus 3 times x minus 1 is my least common multiple. Right, I have two distinct primes, x minus 1 and x minus 3. The biggest power of x minus 1 is 1. The biggest power of x minus 3 is 1. So I have x minus 3 times x minus 1. Or you could write x minus 1 times x minus 3.
Wait, wouldn't the biggest power be 2 since there's 2 of each?
Which one of these is which one of these is squared?
Oh, those are squared.
Which one of them is squared?
Wait. The
None of them, right?
Oh, yeah.
Right? It's this to the first, this to the first, this to the first, this to the first. Right? Because there's two of them doesn't matter.
Okay.
No. The exponent is what matters. The exponent on each of those polynomials is 1.
Okay. Yeah, it's
Is it just like making, you're just like making them all like over the same thing, right? Kind of.
My goal is to multiply both sides to have no fractions. I don't want to make common denominator. That makes things more complicated than it needs to be. What I am doing is I'm getting rid of all the fractions, period. So after I multiply by this least common multiple, I will have no fractions left in my equation. okay? Right, like when I looked, this is what I got after I did the LCM, no fractions. This is what I got after I multiplied by the LCM, no fraction. That's the goal. Don't want the fraction. Cool?
Yeah.
Okay, that's why this method is called clearing fractions, because I get them out of here.
Okay.
Because who wants to deal with fractions? Anybody? Nobody likes them. They're fine, they're numbers, I accept them, but like, if you give me a choice, fractions or no fractions, which one are you gonna choose? No fractions, that's what this method is doing. It's turning it into a no fraction problem. Everybody's okay? So now I multiply this to each fraction. Sure.
And the way that I would stay positive.
If I look at this first fraction, what do you notice?
X minus 1.
If I look at the second fraction,
X minus 3.
if I look at the third fraction,
Both
X minus 3 and X.
so we have left 2x squared minus 6x plus x minus 1 equals 2. What do you notice? What do we have left? What type of equation? Polynomial. How do I solve a polynomial? It's got to be equal to 0. So I'm going to subtract the 2 over. I'm going to combine these like terms also.
Now factor.
Time to factor. What do you notice though about this factoring problem?
You have to do the 2 times the 3 on the top.
Yeah, we have that leading coefficient that's not 1, so it makes it a little bit more complicated. What could you do instead of trying to do the more complicated factor? I would do the quadratic formula here, because I'm just not interested in trying to factor this using the long method, particularly since it's difficult to tell at first glance even if it's going to be factorable or not. So I would just use the quadratic formula here. Now this one will factor. So negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So I have 25 minus, plus 48, right? So 24, that's 49. The square root of 49 is 7. 5 plus 7 over 4 is 12 over 4, that's 3. 5 minus 7 over 4 is negative 2 over 4, which reduces down to negative a half. Am I done? No. What do I need to do still? Check. Where do I check at? The very beginning, the original equation. Where am I checking at? The denominators.
All of them?
Yeah.
Okay.
If I plug in negative a half, do I get 0? Do I get 0? Do I get 0? Negative a half is good. If I plug in 3, do I get 0? Do I get 0? Yes, I can stop. If negative 3 gives me a 0, that's what we call an extraneous solution. We cross it out. We just keep the one that doesn't give us a 0 denominator. Yes. What would we write if all of our solutions are extraneous? No solution. Bingo. Alright. You ready for another? I
Yes.
think this is the last one. Let me double check on that before I have to eat my words. Yep, that sounds good. This is like D or something, I think we're on. What type of an equation do we have?
Rational.
Rational. How do I know?
Because they have x's in
X is in the denominator. How do I solve a rational equation?
LCM.
Multiply both sides of the equation by the LCM. X minus 3, that's prime, that's ready to go in. X minus 1, that's prime, that's ready to go in. X squared minus 4x plus 3, that ain't prime. What should I do? Factor. How does it factor?
X, minus 3, X minus 1.
Good. What's my least common multiple then of the 3?
X minus 3 times X minus 1.
That's correct. Are you getting it, Addie?
Yeah, kind of.
That's a good sign. Yes, sure. So I'll multiply both sides of the equation by that LCM. Whoop, whoop, whoop. Everybody okay with how I multiplied that through?
Makes sense.
What do you notice?
We can reduce.
We can reduce. From the first fraction, I can reduce.
X minus 3,
From the second fraction,
X minus 1.
from the third fraction,
X minus 3 and X minus 1.
excellent. So just distribute some stuff through, oops, distribute some stuff through. Oops. You guys feel okay with what we got? What type of an equation is this now? Rocco? Polynomial. How do we solve a polynomial? It's got to equal 0. So I'm going to move everything on to the side with the x squared because it's usually easier if the leading coefficient is 1, not negative 1.
Can you make sure? Add the like terms?
Yep, I'm going to do that on the way.
Sorry.
Does that feel okay? Okay, how should I solve this now? What's that? Okay, how does it factor? Are there two numbers that multiply to give us positive 4 and add to give us negative 3? Let's start with the things that multiply to give us positive 4. 1 and 4. Does that add to give us negative 3? No. Right, that gives us 5. Negative 1 and negative 4. Nope, that adds to give us negative 5.
Oh.
2 and 2. Negative 2 and negative 2.
That gives you negative.
None of them add to give us negative 3, right? Oh no. So we use the quadratic formula, yes. Oh boy. Nine minus 16 is negative 7. What's the square root of negative 7? It's the square root of negative 7. No.
Oh. Yeah, 0.
No, what's the square root of negative 7?
Something.
7i.
I square root 7. What is this? What kind of answer am I getting here?
Imaginary.
Imaginary. What does that mean?
It's not a solution. Wait, could you write out, or can you just tell me what the quadratic formula is again?
X equals negative 8 plus or minus square root of. What is it?
Addie, you should be embarrassed.
I'm not, I don't get embarrassed.
Oh, okay. Well, that's how nice for you.
Yeah.
Can I?
Yeah.
So you're taking it?
All right. At this point, you guys should be able to do 25 through 32. That is your next part of your problem set.
Does that do, this is Sunday, next Sunday?
Yeah, that sounds good.
Thank you.
What'd you think of this?
It was alright.
Yeah. Again, it's the way I'm presenting it, same way every single time, right? They typically don't get bad if you do it the same way every single time. I will warn you though, if you get to a point where it's like, I can't solve this by factoring, it means you didn't multiply by the least common multiple, right? If you get something where it's like, why is there next to fourth in this? What am I supposed to do with this? It means you didn't do the least common multiple. Okay, you should have something that's you can handle without having to do synthetic division if you've done this properly. Mostly because I didn't design any problems that are that nasty. Okay? But that's it for me.
Thank you for teaching us.
Grace, it was a pleasure.
You just headshot in your face, calling
This is such a random question.
Yeah, go.
It's not about math.
It's all right, I got random answers. 42.
What's Mr. Davis's first name, so I know?
Edmund.
Edmund? Okay.
That is correct.
I've never had him, but he's the testing room guy, I think.
He is the testing room guy.
He's nice.
He's chill. Oh yeah, I have to take my test there tomorrow.
Yeah, you do. Get it,
I'm
Addie.
gonna fail.
Abby, I
that.
got an 82 on that test I took.
What?
Let's take SAT.
I'm sorry.
I'm a bad tester if you can't tell me your goal.
It's okay, Grace. Tomorrow I'm gonna fail my math test, like actually bomb it. It's gonna be fun. So.
It's alright, I'm a senior.
I'm a senior. My option
You have to retake
Yeah,
options
it's
still.
fine.
Oh, I'm not retaking.
I can't. I'm just gonna give it up.
I understand. I'm just presenting that like
This is the
almost
hardest-
anything you can do.
This is the hardest math class I've ever taken in
You
my
just
life.
have to sign homework, because I gave it up to Glenn, because it was stressing me out and taking my time from training.
Okay,
So I think you need to stop signing homework.
I'll take that
We're
under
almost done.
advisement.
Isn't that crazy?
I gave up taking advice from students.
Oh, sure.
What now?
Roast battle.
Dang it.
What was my other constant?
Oh.
I also gave up taking finals.
Better pick up your game in this class then.
Uh-oh.
What's that?
Once I turn in the homework, I'll be chilling. I do it all, I just have to take pictures. Straight to send it.
Yeah,
It's a lot of work.
is it?
A little bit.
Wait, yeah, Mr.
Wait, was last
Was mine?
week 15 through 35 or was it just 15?
Oh, I see.
One through
There's
24.
Sundays was 1 through
This is Siege
24
Mobile, you can.
from
just
chapter
24?
14.
No kills whatsoever.
Man, I was out here doing 29 and
They're saying.
all this stuff.
Well, that's part of tonight's.
Yeah, you were trying to explain this to me, like doing something over X and stuff.
Wait, yeah, okay, wait, what, do you know what I'm talking about? This is my tutor taught me it, but she said it was for age. But she just she said to put everything over X, then change X to infinity, and if the top number is over infinity, then it equals a 0.
Okay, so that's the same thing as the degree of the numerator being less than the degree of the denominator, means the horizontal asymptote is y equals 0. That's correct.
Wait, Mr. Cool,
It's, I think, a more complicated way of explaining it, but that's accurate. She is giving you good advice. That's a little bit more of a calculus perspective.
Oh,
That I think is like more than you need to do what we're doing here, but it's not wrong.
okay.
Yeah, with a little, you giving me a little bit more there, now I understand what you're saying.
Yeah.
Will my homework for chapter 13 be late, since I was like missing all that stuff? Like if I get it all turned in for tomorrow, cause I have it done, I should have turned it in.
Let me think on it. I, like, that's maybe fair, but how long you been sitting on completed assignments?
Well, I know, but I'm also doing, I don't know, the review, I just like haven't really thought through.
No, I understand, but like, why not just like send an email in when you got part of it?
Just sitting in the corner.
Be like, hey, this stuff's done, like,
I'll do it all today.
okay. I'm just, you know,
Well, I know.
I'm not trying to give you a hard time. Remember, there's 2 drops anyway for the homework, so like,
Yeah, but I really can't have it be late, cause I know tomorrow I'm gonna do bad.
Overtime.
I'm so bad at math this year, I know it's fine.
Bro.
I don't know.
Okay, it's over.
I don't think it's bad.
I'm not as good as I am.
I am not. Don't even stress.
He's on Benzo.
I'm for the small P, none of the succeed.
I don't, so did you, were you not?
You said it.
No.
Oh, we didn't.
It's all written down though for
So
you,
Rocco,
Mary.
we're not going to.
Yeah,
On
I'll go
OneNote.
look.
You were,
I'll look later.
you were gone for more than 6 minutes.
You were, definitely.
Sorry.
Yeah.
No, I have an email that had test.
I'll look